So Astrid?
Yeah, okay, thanks. I share my screen. Okay. Can everybody see it?
Mm-hmm.
Okay, great. So I'm a PhD student in philosophy of biology. And as I'm sure you already noticed, I'm not an English speaker. So I'd be very grateful if you could speak slowly when you ask your questions so I can fully understand them. So the topic of my presentation was a relational definition of life for astrobiology. So yeah, I add another definition of life, sorry. But this one is different. Relational biology, the branch of biology I'm working on, developed a model for living systems that its main actor, Robert Rosen, hoped so describes sufficiently living entities. The main idea is that what makes life unique is the way the relations inside the organism organize it. So the leitmotif of relational biology is throw away the matter and keep the underlying organization. And in that way, it's opposed to a reductionist approach, for example. So that relational definition of life is represented in the MR system, which is a theoretical mathematical representation of an organism. The M and R stands for metabolism, repair, and replication. So that model contains three processes standing for those three main functions, which, as I said in my presentation, those functions aren't exactly the ones we consider in molecular biology. Using the theory of categories, Rosen created a very abstract model. It means that those functions might be realized by very different organs or materials, even in well-known terrestrial living systems. The central idea in relational biology is to focus on what organisms do instead of what they are. What we need to know is whether or not those functions cause each other in an efficient way. And efficient here is understood in an Aristotelian sense. And that's what actually is contained in the relational definition of life. Organisms are material systems closed to efficient causation. This model might be useful, or at least usable, for astrobiological researches and has advantages over other definitions of life. First, even if it's a diachronic definition of life, we have to wait to recognize the functions, the processes that we can later translate in the MR system. It's diachronic, we need time, but shorter time than for definitions based on evolution or adaptation, for example. Because for those definitions, we have to wait for generations and generations to recognize signs of evolution. So relational definition of life is diachronic. We won't immediately determine if that stuff in front of us is alive, but at a very shorter time scale. And second, it allows us to think of very different materials for living systems. We can, for example, imagine life without carbon. What I presented here is a different way to think of living systems that might actually help us if we find ourselves in front of potential life. But it will not show us where to look for that potential life. I hope that short reminder is enough to help you to reconnect with my presentation, and I'm all ears for your questions or comments. Thank you.
Kelly, unmute yourself.
Okay. Yeah.
Okay, Eric Hughes. You're muted.
I think my audio is not working still again.
Well, I can hear you.
Oh, good. It's been, I have problems with Zoom because of the way I'm running it. The question I had was that the categorical model, as I should also preface that I actually know some category theory, so it's, as a proper mathematician, you end up getting exposed to it. The categorical model that's in Rosen's development is models organism-based life, which is to say something that has a body boundary and has a reproduction process and perpetuates itself by going through multiple generations. Is there a categorical way of modeling life that's not organism-based? Like you can imagine an intelligent monad, a single thing that doesn't have the same kind of evolutionary process we did because it's not organism-based, that arises and we would recognize as life. These things appear in science fiction, but it doesn't seem to be modeled by the MR model that Rosen has, because it has too much specific entailments to the way that life appears in organisms.
Oh yeah, I think you're right. I'm not sure that it can work, or I don't think of a way that it can work without, as you said, all of those features based on organisms. So I think we can try to find a way, but I think, yeah, as you said, it's actually, as I said in my presentation, Rosen developed that model by looking at a cell, and so it's very based on that, on those observations. So I'm not sure. Actually, I don't think of something that in the theory of categories that can help us in a direct way. Actually, yeah, I don't know right now.
The reason I've thought through this issue in terms of how to get it the proper level of abstraction, and there's a theorem of Ilya Prigogine about complexity creation in dissipative systems. And so the presence of a dissipative system seems to be necessary for life. And that, as soon as you have a energy gradient, you can start categorizing that. So that provides a first basis for where life might exist. And then you'd have to layer on some other things after that in order to get at it. But it does seem possible to take that categorical approach, which when it works right is really, really powerful, because it gets at abstraction at its maximum possible level. But it seems to me you could get at a physical basis of what we would recognize as life, and in fact be able to get a category that overestimated what we would finally recognize as life once we encounter it. It's not going to be perfect, but we should err on inclusion in terms of our definitions of life prior to actual exposure with it.
Yeah, I think you're right. And as you said, in Prigogine's works, there's a lot to look for. And yeah, I'm working on it too. But yeah, thank you.
Okay, John.
Yeah, thank you, Astrid. This is really fun. So I'm seeing in the chat, Sarah Walker's work is coming up. I'm her PhD student, so that's something that I've thought about before. I think my main question is like, when you come up with these functors of like what categories you're defining as, how do you decide what those are? Like what tells you that that's a category that should be needed for life versus this category is not that important? And so I think like there's a way to like almost break down, like say metabolism. You can do chemicals and reactions, and you can look at that. But how would you decide like metabolism versus energy? Like where are the breakdowns in that section?
That's a great question. Thank you. I think that, yeah, you can focus first on what we know. So our energy is kind of material stuffs, and And I think that we have to try. So we can pick one and just, okay, if we want to think that that kind of energy or that kind of matter might be a good candidate for a category. And after we try and just, okay, what are the relations we can create between that kind of category if that's this, and after we just, yeah, I think that we have to try and watch what works and what will not. And so I think that for practical reasons that we can first try with what we know works for life on Earth. So start with carbon and water, and when we find a system and that we think is a system and that might be alive, we can just analyze the materials and think, okay, this one might be a good candidate to be a category, and so we translate it in the theory of categories, and we can see what kind of relations it has with other stuffs inside that system.
Okay, Lucas?
Yeah, I thought this was really interesting. I guess as an Aristotelian, I feel that the environment acts as an efficient cause in evolution. So I'm wondering how you distinguish between the environment as the efficient cause and, say, progenitors as an efficient cause.
Yeah, good question. Actually, I don't know. I'm really sorry. I don't know. I never thought about that yet. Now I have to. And I don't know. I always, well, maybe that's because I'm working on it, but I always thought about the environment as material causation. So with the exchange, the flows of exchange of matter and energy. And of course, I think that it might act like an efficient cause on the organisms, but maybe at another level, I don't know. But the idea in relational biology is that it's closed under efficient causation. So it might have other efficient causations coming from outside, but it has to have one closed cycle, where all the efficient causations are taken into. So, but yeah, for the environment as a efficient causation, I really don't know at that point, but thanks for that question.
All right, Eric Pearson?
Great, thanks. I think this approach was really interesting. I think your focus on relation and behavior rather than chemical basis is probably more promising. My question, maybe already answered it, but I didn't get it. But my question is this, which like hierarchical level is this supposed to work on? Is it the cell level or the individual level or both, or yeah?
I think it will work in an individual level, but that's actually a really good question, and that brings another one. I think that can relational biology make a distinction between organisms and biological entities. As we can see that, for example, we are made out of cells, for example, but it's just a cell alive, like cells inside our bodies that are making us. Is that just, it's not an organism in itself. So I think that the idea, the definition Rosen proposed is about an organism, not just that biological entity. So I think it would work in another way, or maybe there is something that would not work or would not fit the MR system in just biological entity. That's what I think, but I don't know if that answers your question.
Yeah, I mean, can you with your model say that, I mean, distinguish between a living one cellular organism as being alive, but saying that one cell in a bigger organism is not alive.
Yeah, I'm not sure that the model can, yeah, put the distinction between those. I think the model just fits for organism in itself, so individuals, not for biological entity, and maybe it's not just a major difference we can do to that model to have a proper definition of biological entity and that are not organisms, but I have to work on it.
Okay, Nick.
My question is largely related to what Eric Hughes and Eric Pearson were asking about, but from a slightly different perspective. If you apply the relational biology definition of life to a eusocial superorganism like a termite colony, does that end up being an organism? Is the superorganism an organism, or is it only a biological entity to which the definition doesn't apply?
Thanks, that's also a very good question. And actually, I plan to work on it too, because I'm interested in Gaia theory and stuff like that. What if planet Earth was an organism or was alive and contains a lot of different organisms? That's a really good question. And I think that might be the case with the model as it is. So I think that it's very interesting to think that way, but it can be too large actually to just put the discrimination between what we call organisms, biological entities, and maybe superorganisms. So I think it can fit maybe in a way also for superorganism, as you said, or even planet Earth in Gaia theory or stuff like that. So I think same. I have to think about this in another way and try to fit, and what might be the differences if we want to discriminate, or maybe we can't, and we can just say that Earth is alive because it fits it, and so why not? Why not living entities or organisms are also made out of other organisms? What can that change in a way of thinking and considering life, maybe?
Okay, Andrew. Andrew?
Yeah, I'm sorry. I think a lot of my question has sort of been answered by the previous questions, but I'm just concerned. I don't really understand this. The theory of categories, how does that deal with the evolution of the individual organism? For example, a fetus contains different things than the adult. And how do you cope? How does your theory of categories cope with that without referring back to the physical at every stage?
Yeah. Thank you for your question. Actually,
you said at the beginning that Rosen threw out the material.
Yeah.
I'm sorry, I didn't mean to talk over you. Yeah.
No. Sorry. My bad. Yeah, you're right. And actually, that's a very good question. And I couldn't say, of course, everything about rational biology and that, but they're not totally throwing away the matter because the way they are describing it, at some point they want to go back to physical entities, and they want to match that model to real entities and physical entities, because as you said in that definition, organisms are material systems. So yeah, we have to find matches of that model to real organisms. And that's the tricky part, because at some point I think it's not really working. So it's a great abstract model, and it helps us to think in another way, but it doesn't always work, because we are going so far in the abstraction that at some point we can't go back and and actually recognize if that's a good model or not, because okay, maybe we can start from the cell and start describing stuff and going in the abstract level with mathematical tools and stuff like that. To go back. So there are work about that, like Louis Rosen's students is still working on it, and he's trying to, at some point, not just that point, but he's trying to find, okay, what, for example, the metabolism in the MR system, what is it in well-known terrestrial organisms like in human or others? That's what I call the realization problem. We can't find a proper realization. We can show the way to realize MR systems in actual organisms, because that's what ultimately we have to do.
So it's pretty mathematical, really, in all mathematical groups, transitions,
at some point, but I think that it might be more than that. If I think, but it needs a lot of work. But I think that it might be very interesting that to just, not stay at that mathematical level and at some point going back.
All right. Great. Thanks.